All right, let g be the function with first derivative. G prime is this ugly mess. Which of the following must be true? Okay, so they ask you a bunch of questions about g prime questions, right? This is g prime sign info, right? And then they ask you a bunch of questions about g double prime sign info, right? So basically, your job's going to be to look at the sign of g prime and to look at the sign of g double prime. So here's what I know, okay? I know that this thing, right, this is the area under a curve that is definitely above zero, because that's how E stuff works, right? Like, remember, this is a positive number, meaning that g prime of x from 0 to 2 is definitely positive, because this is a positive area, right? Like, g prime of x is the area. Sorry, it got all frozen and it's beach balling. Okay, because g prime is an integral. So I know g prime is positive. Once I know g prime is positive, I say, cool, g prime is greater than 0, so g is increasing. Great. So I cross off some of those answers, right? Next, I'm going to go ahead and look at g double prime. Well, if g prime of x is the integral from 0 to x of e to the negative t squared dt, then g double prime, by the second fundamental theorem of calculus, is just what happens if I differentiate. And that's going to knock out this integral, and I'm just going to be left with e to that stuff, d stuff. So these get knocked out, right? And I get that g double prime is just e to my bound, d bound, minus e to the bound, d bound, but that one gets knocked off. So my g double prime of x is an e to the negative x squared, which for the record is also always positive, because e to a power is always positive. So once I know my second derivative is positive, I can say, oh, g double prime is also positive, so g is concave up. Cool, that crosses off this guy, it's A, right? It really is about looking at the questions, looking at the answers, and trying to go the shortest path to what you need to get. All right.